Greetings everybody, this is the second video for online lab number 8 collisions. Now for sheet 2 we're going to run the simulation for an inelastic collision. Now before I get to that, let me notice all the data that we enter, the count for the masses, the momenta, and the equations. Notice I've just added 3 columns: initial kinetic energy, final kinetic energy, percentage of kinetic energy lost. And notice that I've already entered the formula for the percent kinetic energy lost. It's simply, the formula is, it's the KE initial minus KE final, all divided by KE initial, then just times 100 to convert it to a percent. Very basic, so I've entered it for you. Now remember, notice the equations for theta 1 final from X, theta 1 final from Y. Well, notice all the cell references are the same. Notice here, the formula here, respect to that formula is J10, K10, M10, N10. Well, notice sheet 1. Notice J10, K10, M10, N10. So all we have to do is just copy these formulas and paste them into sheet 2. And you can do that before or after. And then once you do that, then just drag down. That's why we love Excel. It makes our lives a lot easier. Okay, so in sheet 2, what I'm doing is I have to run the simulation for the inelastic collision. So what I'll do down here, see at the bottom, inelastic. Okay, I'm going to click there. I want to see momentum. Definitely need kinetic energy. Elasticity 0%, and I want stick. I want them to stick together. The momentum diagram, you can put it or not. I want slow, more data. Okay, now watch what happens is when I run the simulation, they're going to collide and they should stick together. And again, we're going to do it, let me just go back for same as sheet 1. First time, M1 0.5, M2 1.5. Then M1 and M2 both equal to 2 kilograms, and M1 3, M2 1.5. So, but that's not changing. So let me go ahead, run the simulation. Oh, I forgot values. We need values. There. In fact, let me restart this. Okay. Yep. Everything's good. And now remember, see the more data table? Right now, these are the initial quantities. For the spreadsheet, I want the final. Okay, so we can't we can't populate the spreadsheet until we hit play. So everything looks good at play. They collide. Pause. Now it might be a little bit, and you can see P, where it says P equal to 0.12 kilogram meter per second. That's your P1 final. See where it says P equal to 0.53 kilogram meters per second. That's your P2 final. Okay. Then right here, what is PX1 final? 0.06. What is P1Y final? Minus 0.10. What is P2X final? Minus 0.19. What is P2Y final? Minus 0.5. Well, let me go ahead and let me enter those. Let me pause the simulation while I enter those. So let me just run the simulation again real quick. I'm going to hit play and then pause, and there we go. Actually, let me do it one more time. So I'm going to hit, and that's why I wanted to reset it. Notice the kinetic energy, 0.65 joules. That's the initial kinetic energy. So you want to enter that right here in the KE initial. Okay, that's how you get that. Then KE final we'll get to. So I'm going to go ahead back to the simulation, hit play. When they collide, then pause it. Looks good. So you can see P1 final is the 0.12. There it is right there. The P2 final is the 0.53. And it's 54, 0.53. Okay. Okay, then P1 XF, P1 YF. That's right there. See this? Remember this first row. This is right here. P1 XF is minus 0.07. P1 YF is minus 0.1. I'll 0.06. I'll do 0.7. Not gonna 0.07. Not gonna matter. All right. Then P2 XF is minus 0.18. P2 YF is minus 0.5. Was it 1.8 instead of a 1.9? Okay. And then now what about my final kinetic energy? Well, right here. Kinetic energy is 0.11 joules. And so I've already got the joules there. So now watch what happens to the percent KE loss when I enter the set. 0.11 and hit check. Yeah, see, it lost 83.08%. It lost 83%, a little over 83% of the original kinetic energy. Now, what about the angles? Well, remember, let's look at the J and K columns. Theta 1 F from X, theta 1 F from Y. Well, I don't have to reinvent the wheel. Go back to sheet 1, take the formulas, copy, paste. Look at that. Okay. Now, what about percent difference? Well, I don't know. I didn't copy it with the other. I should have just copied all three together. Copy, paste. Now let's do the same thing for theta 2 final. Let me go to sheet 1. And here I'm just going to copy all three. Copy. Go to sheet 2. And click there. Paste. Look at that. Now go ahead and now you've got your formulas in. Remember, after you fill out, I would go ahead and get the data I will go ahead and get the simulation data for those masses. Then just go ahead and what do you do with the formulas? Remember, when you have the crosshair, hold down the left mouse button, just copy them down. And we're good to go. And remember, how do you get the initial and final kinetic energies? I'll show you real quick. Let me go ahead and set the masses now to 2. 2.0, enter. M2, 2.0, enter. Okay. Why is it not? I just have to, yeah. I know, let me pause this. I don't quite know what's going on there. Okay, so now I've got M1 and M2 both equal to 2 kilograms. It's perfectly inelastic collision. Momentum diagram, you look at it or not. Okay, I'm going to hit play. Oh, values. Okay, there we go. Hit play. Pause. There we go. Oh, yeah, but there's the initial kinetic energy. I hit restart. That's the initial kinetic energy. That's your KE initial. Then you go ahead and hit play. After they collide, wait a second or two, hit pause. There we go. And again, now enter in all your values, and you're good to go. So I think that explains everything for Lab 8. Let me go ahead and save this video, get everything posted.